Okay, we're going to be working on problem number 49 in section 4.4, page 310. Maximizing profit. A division of Chapman Corporation manufactures a pager. The weekly fixed cost for the division is $20,000, and the variable cost per producing X pagers per week is... So they give us a variable cost function, and that calculates the dollars. The company realizes a revenue of, and it gives us a revenue function, and also gives us a closed interval from 0 to 7,500 pagers. So these variable cost and revenue functions are applied to X pagers, where X is somewhere between 0 and 7,500. Find the level of production that will yield a maximum profit for the manufacturer. Well, first of all, we've got a variable function there for the cost, but they also have a fixed cost of 20,000. So I'm going to create a cost function by taking the variable cost and adding the fixed cost of 20,000. That fixed cost of 20,000 is established before any pagers are manufactured and sold. They've given us a revenue function for the X pagers at negative 0.02 x squared plus 150x. Now, profit, the profit function, profit is revenue subtract cost. So I've got a negative 0.02 x squared plus 150x minus, be careful, the cost function, which is the variable cost, and the fixed cost have to be subtracted. So make sure you get parentheses around that, because you want to subtract the whole cost function, and we'll have to distribute that minus sign there. So I've got negative 0.02 x squared plus 150x minus 0.000001 x cubed plus 0.01 x squared minus 50x and then minus 20,000. Okay, let's try to simplify that a little further. You'll notice I have some like terms here, and I have some like terms here. So bringing those all together and putting them in descending power order there, I'll have minus 0.000001 x cubed minus 0.01 x squared plus 100x minus 20,000, and I have a profit function. Now, the problem wants us to find the level of production that will yield a maximum profit. So to find a maximum on that closed interval, we're going to have to first take the derivative. So I have a minus 0.000003 x cubed, or squared, I'm sorry, minus 0.02 x, and then plus 100. Of course, the derivative of a constant, the 20,000, is 0. Now, setting that equal to 0 and solving for the x is not something that looks like I could factor very easily. So what I'm going to have to do is to put it in the quadratic formula. And I've got it set up there so that I can read off the A, the B, and the C for the formula. And I'll just plug it all in there. So minus B, now B is negative, so I'll essentially turn that into a positive, plus or minus the square root of B squared minus 4 times A and times C. All of that over 2 times A. Solving this formula gives us x is equal to 3,333.33, and that is in the interval from 0 to 7,500. So because this function is continuous, the profit function is continuous and defined on a closed interval, I just need to check the endpoints, production level of 0, there's a loss of $20,000, which makes sense. That was the fixed cost. And the profit at 7,500 is 167,500. That sounds good. But there's another possibility for the absolute extreme value at 3,333.33, and that is 202,222.11. So the largest maximum amount of profit would be at a production of 3,333 or 34 pagers. The profit would be $202,222.11, and it would occur at that amount. The absolute minimum, of course, would be not making any pagers at all.